Hey everybody, this is Larry. This is me going over day 12 of the September Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join my Discord, smash all the whatever buttons. Anyway, today's problem is reachable nodes in subdivided graph. So I usually solve these live, so if it's a little bit slow, skip ahead or watch it on more faster speed. My point to these videos, and I get these questions every once in a while, and people are like, hey, you can make these videos better by doing this. I'm like, no, this is the point. The point is that I want to have a different video. I don't want to make the same video that everyone else is making, which is just explaining the solution. There are enough videos for those. Google those instead. We live in 2020. What year is this? 2021? Yeah, you can Google, you can search on YouTube, you can find other videos. It's fine. I'm not going to hold it against you. But my thing is that I'm going to give you my thought process, and my thought process is me, seeing the problem the first time and kind of, step by step, even the ways that I solve a problem incorrectly, or yeah, a lot of weird things, so that yeah. Anyway, okay. I hope that makes sense. So yeah, please take that into consideration. Anyway, today's problem is reachable nodes in subdivided graph. Okay, let's see. What does this mean? You have an undirected graph, okay? You have n nodes, okay? You have a chain of nodes with the number of new nodes. What does that even mean? Wow, it's like these nodes have babies or something. Okay, the graph is given to subdivide UV, replace it with count sub edges. How many nodes are reachable from 0? And you give it max moves. Okay. This is very awkward. But let's see. I mean, this is a way. I don't think that. I mean, I was gonna say I don't think I've seen this particular problem, but this is just a very awkward problem. So I mean, it's a graph problem, obviously. But yeah. Okay. So you're just going from 0 to okay, and in this case, max move is 6, so you 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6. Okay. I mean, I think it's still just going to be some sort of Dijkstra's algorithm. Why did I say Dijkstra? Dijkstra. Because basically you're just doing the cost, except for each of the frontier. I don't know if that's the term, but the frontier edge nodes. On the frontier nodes, you do like a little bit more math on how far you can go in between the edges. Okay, so this is I wanted to confirm certain things. So this is the undirected graph, which means that, yeah, I mean, I think there are also a couple more scenarios, meaning that, for example, let me pull up Paint real quick. But still, I think it's going to be Dijkstra, maybe. I think Dijkstra gets us a lot of the way there. There are more weird cases that we might have to consider, and we'll cross that path when we get there, I suppose. Let's see. So let's say this is my paint, and what I mean by that is that, okay, you have a node here, you have a node here, and you have a node here. And you have this thing, you have this thing, and you have this thing, right? So then let's just say that we can get here and we can get here, and then now you have all these other smaller subnodes that are like, that are here, here, and let's just say max move cuts us off in like some, so one is that for max moves, we're good on this one and everything in between. Let's say we already did the math on that. So then that means that we can tick, say, I don't know, some subset of this, right? And what I mean by that is, for example, this means that, let's just say max move can do this, and then this max move can do this thing, right? And of course, in this case, you have to be careful about how you do the math, so that you don't double count, these nodes in the middle. And I think that's basically the idea behind what we have to do. But otherwise, I think it's just Dijkstra. Yeah, I think it's just Dijkstra, but we have to figure out how to be very careful. And there's even more than that, I think, now that I think about it. So maybe it's not Dijkstra. Let me think about it for a second. But I want to draw again the visualization I was thinking about, is that and we did this and that's okay. And one reason why I don't know if it's Dijkstra now is that because you can still have extra edges, and even this may be good, say, and this could be good, this could be good. Like, let's just say that these are also good. These are also good. But let's just say you add an extra edge and it's this one to this one. Whoops, wrong color, but same okay. Let's say it's this one for this one, and you have some, you have some nodes in the middle. Well, you have to consider some subset of these too. So I think we have to be really careful. I mean, it might still be Dijkstra, but I think we have to be very careful about how we want to do it. So yeah, okay, let me think about it for a second. Okay, so the number of edges is going to be 10 to the 4th. Is that 1,000? No, that's 10,000. So 10,000 edges. So we only have 10,000 edges we have to consider. We can also make... What is n? N is 3,000. Okay. So 3,000, 10,000. I was going to say... I was thinking of what is that Re algorithm? Re times Re algorithm. I forgot the people's names, but basically it's the shortest path one where you do for each vertex times for each vertex relax all the edges, and then you do that Re times or Ye times maybe, and then that should be good. But that would be too slow in this case. So yeah, I'm blanking out the name right now, but. Leave that in the comments if you know, because like I said, I'm doing these live. But okay, I'm still trying. So Dijkstra with a lot of if statements is going to be my guess, but we have to be careful. Okay, there are no multiple edges. That's good. UVN, okay. I mean, I think we should still be okay. Because for each edge, we're only at worst going to look at it from, well, I mean, each edge can only be looked at from two places, right? From one endpoint and the other endpoint. So yeah, max move is 10 to the 9. So here, if you had any thoughts about doing DP by max moves, this would be like, nope, you have to do it with Dijkstra. I think this is just Dijkstra with carefulness. So let's think about it, and then yeah, I think we can do that actually. So let's set up the list of stuff. Okay, and as usual, I always change this to a big N just because it's consistent with me. But that's just me. Okay, so for you, we in edges, and is there a count as well? Yeah, this is the count. Yeah, in edges, we're just setting up the edge list. Let's call this, let's just say Z. Default text of a list. Yep. E dot this, we append v count, and then this is just setting up the linked list with the cost. And then now we start from 0 from Dijkstra. Yeah, let's do Dijkstra. I'm thinking about something for a second. No, it should be okay. Yeah, Dijkstra. I implemented this. I think this was a contest solution, like about. This was a contest problem maybe like a month ago, and I had a typo that I really debugged for a while. I'm really rusty with all these like problems that I know, that I know I could have done better. But yeah, okay. Anyway, let's do it. Let's just set a heap, and then we set heap dot heap q dot heap push heap. Let's just call it h. I want to add. Yeah, and then this is node 0 or 0, 0. This is just a lot of if statements. I think that's the thing. But yeah, while length of heap is greater than 0, we have to do more things here, by the way. Of course, we have to do shortest path. Yeah, okay, because then that gauges how far we can reach out from here. Actually, I think the shortest path is already good enough. Then we can look at each edge and then determine how far. Okay, I think that I was going to do something way more funkier, but now that I think about it, I think we can just look at we can just use the distance in the Dijkstra, and then for each node we can look at all its neighbors and then do the math that way. Okay, I think I'm happy with this one now. Okay, so yeah, let's just say we have this is equal to I don't know, whatever. Infinite times n. Oops. Okay, and then now you have the distance and node equals heap q dot heap pop of h. Okay, and then now we go for v in g sub node, or for v count when g sub node. Let's double check the math for a second, because here if there's one count in between, then it takes 2 to get to 2, right? So then yeah, also I misspelled heap. If distance of v of count. Oh, sorry, I'm getting distracted. People keep pinging me on my phone. Okay, let's do this. Okay, if is greater than d plus count plus 1, then we want to set this equal to d plus count plus 1, and then put that on the queue. Let's see, we push new distance and the node. Yeah, okay, this is okay, right? Why does this feel so too short? I feel like I'm missing something really obvious, but okay, fine. Yeah, and then if d is greater than distance of node, we skip and we continue, so that we don't process the same node more than once. Okay, and then now we should have the shortest path from everywhere. Let's see. Let's take a look real quick to see whether this should be good. He push got 2. Oh yeah, I always forget, because the syntax is very awkward in Python. 10.4, and let me just copy and paste these things in. Okay. Okay. Let's run the code real quick to see if the shortest path is good. Let's see. 0 is 0. It gets to 1 and 11. Okay. Gets to 2 and 2. I guess that's right. Assuming that this is 10. Okay. Okay. And then here is just a lot of infinities, and here we have 5 and 9, and then max is 23. Okay, and then now we can look at it for each node, and then we can calculate it for each edge, right? Yeah. So okay, so then now we go for each edge again. We count in edges. Okay, so how many gets used, right? So that's a question. So total is 0 for now. Then that means that how many nodes of this edge gets used? So that is the question. Okay, so yeah, okay, let's first of all, okay, um, I mean, I know the math, but I know the theory. I have to think about the math to be precise. It's a little bit tricky. So that now you have two things, right? And then this is basically the couple of examples. One is that they don't reach each other. So that means that max moves minus this distance. So this is, let's just call it from the left. It's not really from the left, but I mean, or like, you know, there's no left rights. But yeah, so then now this is from the right, and then total we just added to min of left plus right. So left plus right, or max, or not max moves, or count, because that's the number of things in the middle, right? And then now we can return total. That's not, we don't consider the original node, so now we just do the original nodes. So here, if this sub I is equal to infinity, no, it's not equal to infinity, then that means that it is reachable. So then total we increment by 1. Hopefully this is good. Yikes. Oh, I guess these can be infinity as well, so that's why. If, okay, well, okay, fine. Let's just set max of this or 0, so that this basically gets at least is either 0 or nothing. Okay, so we're close, not quite to, obviously, but we're close. I think we're on the right track. So what do we get wrong? Let's see. And I think, yeah, we're just having off by once. So yeah, okay. Right now the path here, I think we need to, yeah, this distance is 1 because, wait, is it? Max moves though, right? Not, let's run it real quick. I don't think so though. I think this is still, is max moves from 0, so it doesn't count the node 0. Oh no. Yeah, I don't know. I think this should be still be 0. Okay, because I think that's just max move. So then it takes count number of moves plus 1 to reach the new node. Yeah, I think that's okay. Why do I have 12? So that now there is max moves. Let's say we're coming from max move to the left. Then that means that we can make that many moves. I'm not convinced that I know that what I'm doing is wrong, but I'm not convinced that my logic is wrong. I just think I have something weird. Maybe. So, okay. Why is, let's just print it out then, fine. Technical difficulties. Okay. So from the left it gets 10 or 6, and it's 0. And we have 10 in the middle. So we count all 10. No, we only count 6. So 0 and 6. Is that right? I think this 0 is a little bit awkward, right? As you go to the max move minus distance of v. Alright, let's just do uv so I can kind of see. Maybe I'm just confusing things. Okay, so 0 and 1. 1 is 10 away. Yeah. Oh, wait, max move is 6. Oh, I was thinking about the other example. I think that's why. Maybe? Well, yeah, so there's 6. 1, 2, 3, 4, 5, 6. So that this should have a contribution of 6. Okay. To the other node, it's 6. So it's 1, 2, 3, 4. Okay, so it takes 2 moves to go to 2. And then 2, now we look at each edge next to it. And okay, so for the O2 edge, we have 1, right? O2. Wait, what is this count again? Oh, no, this is the count. Okay, yeah, of course. Because you can't do more than this count. Okay. Yeah, okay. So what's wrong here? Let me also print out the total. No, I mean, it's fine. Okay, so far... okay, fine. That's... I don't have to do things in my head if I just print it out, right? So, yeah. Okay, so it's 6 plus 1 plus 2. Is that right? 6 plus 1 plus 2. Okay, so you could get to 1. What is the distance to 1? So there's an extra 1 that off 1. What is the closest distance to 1? It should be 1, 2, 3, 4, 5. So, okay. So let's print out distance, I guess. Okay, so this is giving me 11. So that means that my dice draw is wrong, I think. So that's why. Ow, what am I doing here? Whoops. What a typo. Okay. I've been just really bad with these typos lately. Okay, fine. And then now we're Gucci. Because the distance now is calculating correctly because, yeah. Okay, let's give it a submit. And I'm so sad about it. Oh, no, okay. Well, now I'm even more sad about it. Okay, let's see. I guess I should have checked the answers as well, but I got a little... I was like, oh, this must be it. I mean, that is a big portion, and we did fix it, but yeah, I don't know why we didn't... Yeah, should be okay. Let's see. What is this one? These graph problems, I always have to think about how to draw these out in these cases. So that's a little bit sad. I think the one thing that I didn't consider is about going for 2. No, we did go with 2 notes here. So, okay. So we're just getting off by 1s, I think. Okay, let's print out the distance. So then now we have 07942. Is that right? Probably. I mean, that is dice draw. It should be okay, right? Because you have 0 to 3 is 4, okay. And then 0 to 4 is 2, also good. And then now 3 to 1. Okay, 3 to 1 should be, so now it's 4 plus 3, so it's 7, okay. And then 3 to 2 is 4 plus 5, so it's 9, okay. And then, did we miss anything? What is this for? Oh no, we got, this is the 3, so I think we're good here. At least in the distance one, double checking. And now we have to do for each node. Okay, so between 1 and 2, there are 5 nodes, but one is 7 and the other is 9. Do I have off by 1? No, we used up all the moves here, so then the contribution is 0. Okay. So then here we have 6, 8, 9. Oh, I know. I actually was thinking about it when I was coding it, but then I got distracted by the infinity. So okay. So yeah, so we only count these nodes if, obviously, if this there we can, if we can get there. So okay, how did this work for this one? Oh, for this one, it's just that it's not connected. But here it's connected, but it's too far away. Okay, I thought I tested it. That's why I didn't think about it. But yeah, okay, cool. Yeah, so I mean, I struggled a bit with this one as well. So yeah, yikes. But yeah, but overall, this is just dice roll. I think the hardest part for me is that you have to think about the cost instead of the edges. And then once I thought about, okay, I have to process all the edges independent, or it doesn't have to be independently, but I have to process all the edges. And then now I think about, okay, backwards a little bit. What does that mean for me, right? And that means that each node has, that means that from each edge you can go from the left and the right, and that's kind of basically the idea that we have. Cool. So yeah, so dice in this case is going to be let's say O of V log V. Technically this is O of V log Y, the way that we implement it, but as a result, keep in mind that this is roughly V log V, roughly. Because y can be v squared, and then you take out the 2, right? So yeah, and this is going to be dominating because this is just O of y, and this is O of n, O of v. So yeah, so this is this, and then space is just O of y for space because we have to reconstructed the edge list. Or you can say v plus g, I suppose is more accurate because we have O of v stuff here, and here is O of y, O of y in general. So yeah, which is where you got the log e. But yeah, let me know what you think. Hope y'all have a great week. Hit the like button and subscribe button. Join me on Discord. Hope y'all have a great week. Have fun. And yeah, it's a good mental health. I'll see you later. Bye bye.